So when you have a alkane like this, you basically name it based on the number of carbons. There is a carbon at each endpoint. So this has 1, 2, 3, 4 carbons. If you look at the chart on the right, 4 carbons give you butane. So this is butane. Similarly, if you have an alkane like this, you name it the exact same way. Count the number of carbons. 1, 2, 3, 4, 5, 6 carbons. 6 carbons give you hexane. It gets a little complicated when you have a continuous carbon chain, but you have phenolkyl group attached to it. Every time you have something attached to your main carbon chain, it's called an alkyl group. You can also call it substituent. Before I name this alkane, let me go over some of the alkyl groups that you have to know. Let's say this is your main carbon chain. When there is one carbon attached to your main carbon chain, it's called methyl. When there is 2 carbon attached to your main carbon chain, it's called ethyl. When there is 3 carbon attached to your main carbon chain, you call it a propyl. When there is 4 carbon attached to your main carbon chain, you call it a butyl. When you have 3 carbons attached to your main carbon chain but in this shape, where the alkyl group splits off at the end, is called isopropyl. When you have 4 carbons attached to your main carbon chain, but in this shape where it splits off at the end, is called isobutyl. 4 carbons in this shape is called third butyl. 4 carbons in this shape is called sec butyl. Now I have the chart, the alkyl groups, and a set of rules that I'll be using to name this alkane that I drew earlier. The first thing you want to do is identify the longest continuous carbon chain. We have 3 continuous carbon chains in this alkane. This is a continuous carbon chain. This has 1, 2, 3, 4 carbons. This is a continuous carbon chain and it has 1, 2, 3, 4, 5 carbons. And this is a continuous carbon chain. This has 1, 2, 3, 4, 5, 6 carbons. This has 6 carbons, so this is our longest continuous carbon chain, or our parent chain. And when you have 6 carbon, you call it a hexane. Once you have your longest continuous carbon chain identified, you are left with your alkyl groups. In this case, we have only one alkyl group, which is methyl. The next thing you want to do is number the carbons in your parent chain in a way so that your alkyl groups get the lowest possible number. And this is what I mean. If you start counting from the left side, you get 1, 2, 3, 4, 5, 6 carbons, and your methyl gets the number 3. Now if you count from the right side, you get 1, 2, 3, 4, 5, 6. Your methyl gets the number 4. You want to give your alkyl group the lowest possible number. So in this case, you should start counting from the left side. Now we know our location of the alkyl group, and all we have to do for our final name is put them together. So this would be 3-methyl hexane. This is the final name. The N comes from your parent chain, which is hexane, and the prefix comes from your alkyl group. You must include the location of your alkyl group, which is 3 for this alkane, and there must be a dash between any number and letter that you put. Okay, let's move on to the next example. Okay, let's name this alkene. There are a few continuous carbon chain here, but the one that's highlighted is the longest continuous carbon chain. This has 1, 2, 3, 4, 5, 6, 7 carbons, which is heptane. This alkane also has 2 methyl. Now we have to number the carbons of the parent chain in a way so that these 2 methyl groups get the lowest possible number. Since they are closer to the top side or the left side, we'll start numbering from that side. 1, 2, 3, 4, 5, 6, 7. Now we know the location of our alkyl groups, and all we have to do is put them together. Let me first write the final name and then I'll explain why it's the way it is. 2, 4 dash dimethyl heptane. This is the final name. When you have multiple of the same alkyl group, instead of writing them twice, you just use Latin prefixes. If you have 2 of the same kind, you put di. If you have 3 of the same kind, you put tri. For 4 of the same kind, you put tetra. We have 2 methyl, that's where the dimethyl comes from, and they are located at 2 and 4. So we have to include that in the name. There should be a comma between numbers and a dash between number and letter. We'll start off by identifying the longest continuous carbon chain for this alkane as well. You could choose these to be your longest continuous carbon chain, or you could choose these to be your longest continuous carbon chain. It doesn't matter which one you choose because they both have the same number of carbons and they both have the same alkyl groups attached to them. So you will end up with the same naming anyway. I will randomly choose this to be my longest continuous carbon chain, and it has 1, 2, 3, 4, 5, 6, 7 carbons, which is heptane. Now we are left out with a methyl and an ethyl. Next thing you do is count the carbons of the longest chain so that the alkyl groups get the lowest possible number. We'll start counting from the bottom. 1, 2, 3, 4, 5, 6, 7. Now we know the location of our ethyl and methyl, and all we do is put them together in alphabetical order. The final name is 3-ethyl 4-methyl heptane. When you have 2 different alkyl groups, you have to put them in alphabetical order. E in ethyl comes before M in methyl, so that's why ethyl comes before methyl, and they are with their respective location 3 and 4. There should be a dash between every number and letter and no space between methyl and heptane. Next up we have this alkane. I'll go a little bit quicker on this one since I have covered all the rules. The longest continuous carbon chain for this would be this one. It has 1, 2, 3, 4, 5, 6 carbons, which is hexane. It also has a methyl, another methyl, and an ethyl group. Now we number these carbons so that these alkyl groups get the lowest possible number. Since more substituents are toward the left side, so start counting from the left side. 1, 2, 3, 4, 5, 6. Now we just put this in alphabetical order to get our final name. 4-ethyl -2, 3 dimethyl hexane is the final name. This alkane has two methyl groups, that's where the dimethyl come from, and they are located at 2 and 3, so you have to include those in the name. And every time you put two numbers together, there should be a comma and dash between numbers and letters. 4-ethyl comes before 2,3 dimethyl. That's because E comes before M. Di doesn't count toward the alphabetical order, and that's how you get this name. Here's an easy example. This is our longest continuous carbon chain, and it has 1, 2, 3, 4, 5, 6, 7, 8 carbons. 8 carbons give you octane. And there is a isopropyl group attached to it. We'll number the carbon chain from left side so that the alkyl group gets the lowest possible number. 1, 2, 3, 4, 5, 6, 7, 8. Now all we have to do is put them together for the final name. 4-isopropyl octane is the final name for this alkane. This is the last example for this video, and it's a bit tricky one. This is our longest continuous carbon chain, and it has 1, 2, 3, 4, 5, 6, 7 carbons, which is heptane. It also has a third butyl and a methyl attached to it. One of our alkyl groups are closer to the top, so we'll start counting from the top. 1, 2, 3, 4, 5, 6, 7. Just like any other alkane, we'll put them together for the final name. 4-third butyl -4-methyl heptane is the final name. Now you might be wondering why third butyl comes before methyl when M comes before T in the alphabetical order, but just note that third and sec does not count toward determining alphabetical order. So whatever comes after third, which is B, counts toward the alphabetical order. B comes before M, so third butyl comes before methyl. And that's it for this video.